Welcome back, you guys, to our second lesson in Unit 3 on quadratic functions. Today we will learn about the other two forms that a quadratic equation can be written in. And so our learning objective for today is we will be able to graph quadratics from standard and intercept forms and identify function characteristics as we have done before. You have seen this before in Algebra 1. F of x is equal to ax squared plus bx plus c. This is what we call standard form. And just like in the other examples and in the other forms, we try to find several characteristics of the functions. And the first and most important one that is going to get us started is, of course, the vertex. Now, in standard form, we can find the vertex by using a formula for the x value. And the formula for the x value is negative b over 2a. And whatever that number is for our x value or x coordinate, we plug into the equation to get the y coordinate. And as you know, the x-coordinate of our vertex also gives us the axis of symmetry. The axis of symmetry is always x is equal to negative b over 2a. Remember, the axis of symmetry is a vertical line that splits the parabola in half, and it goes right through the vertex, and therefore all we care about for the axis of symmetry is the x-coordinate of the vertex. A is going to be our dilation, so we follow the dilation when we start graphing the parabola. And the y-intercept we can find fairly easily by just plugging in 0 for x in both the first and the second terms. Then ax squared turns to 0, bx turns to 0, and what's left is c. So our y-intercept has the coordinates 0 and whatever the number for c is. And of course, we also want to find out if that parabola has a maximum or a minimum. Remember, if it opens up towards the top, then the vertex is the minimum of that parabola, of that graph. And if the parabola opens downwards, then the vertex is the maximum. So let's look at a couple of examples. The best thing to do when we start graphing from standard form is to first figure out what the numbers are that are in the places of A, B, and C. And that's also good practice for when later in this chapter we're going to use the quadratic formula, where we also need those three numbers. A is equal to negative 1, B is equal to 2, C is equal to 3. All right, from that we can now start finding our vertex. Remember, the formula for the x-coordinate is negative b over 2a. So negative 2 over 2 times negative 1. That's negative 2 over negative 2, in other words, 1. That is our x-coordinate. And the x-coordinate we are going to plug into the equation to find our y-coordinate. And we get negative 1 squared plus 2 times 1 plus 3. Now be careful here with the beginning. The 1 is squared and then turned into a negative. It's not negative 1 we're squaring. So 1 squared is 1, turned negative is negative 1, plus 2, plus 3, and the answer is 4. So 1 and 4 are the coordinates of our vertex. That already gives us the information to write down our axis of symmetry, which is x is equal to 1. Then let's now find our y-intercept. If the first term turns to 0, the second term turns to 0, 3 is all that's left. C is equal to 3, so our y-intercept is 0 and 3. That gives us enough information to go ahead and now graph our parabola. So our parabola has a vertex at +1 and +4. Now normally we would go 1 to the right, up 1, 2 to the right, up 4, 1 to the left, up 1, and 2 to the left, up 4. Remember? Now, as you can see, A is -1. That means our parabola gets flipped downwards. It's not getting stretched or squished together in any way, but it's flipped downwards. So go right 1, 1 down, right 2, 4 down, left 1, 1 down, left 2, 4 down. This is what our parabola is going to look like. Remember, we have our axis of symmetry, and as you can see nicely how one side is reflected to the other. And so we are lucky, not only did we already find the y-intercept, but we can also now go ahead and determine our roots just from looking at the graph. Roots, remember, x-intercepts, solutions, zeros, right? So we have one root at +3, 0, and one root at -1, 0. This parabola is open downwards, so it has a maximum, and the maximum is at the vertex, has the same coordinates as the vertex does. Let's look at our domain. As for all parabolas, the domain is x is an element of all real numbers, and the range goes from -infinity with round parentheses as usual all the way up to +4. +4 is an element of the range, therefore we put square brackets around the 4. You should have enough room on your left margin for doing all the side calculations, but do leave some room for our next example where we're going right now. Y is equal to 2x squared minus 4x. And as we did before, we're going to start off by determining the numbers for a, b, and c. A is +2, b is -4, and wait a minute, there is no c. Well, what does that mean? Back here we should have a number, we have nothing, and nothing in math means 0. C is equal to 0. Let's go ahead and find our vertex. -b over 2a would be -8 over 4. In other words, and I hope you all realize that it's of course not -8, it is the negative of -4 divided by 4. In other words, 4 divided by 4, which is equal to 1. Plug in the 1 into our equation, we get 2 times 1 squared minus 4 times 1. 1 squared is 1 still, so 2 minus 4 is equal to -2. And here you got your coordinates of the vertex, 1 and -2, which also gives us our axis of symmetry, x is equal to 1. Let's find our y-intercept. If we plug in 0 for x in both terms up there, everything turns to 0. There is no c, and therefore our y-intercept is 0, 0. And now we have enough points to go ahead and start graphing our parabola with a vertex at 1, -2. Now let's think about our dilation. Normally we would go 1 to the right, 1 up, 2 to the right, 4 up, 1 to the left, 1 up, 2 to the left, 4 up. Instead, because a is equal to 2, we have to double all that. So we go 1 to the right, 2 up, 2 to the right, 8 up, right here. 1 to the left, 2 up, 2 to the left, also 8 up. So this is our parabola, and as you can see, it's thinner than our parent function because it got stretched vertically. Let me put in our nice little axis of symmetry. And we found our y-intercept already. It's at the origin. And you remember that if an intercept is at the origin, then it's also always both intercepts. So this is not only the y-intercept, this is also the x-intercept, or in other words, one of the roots, which is at 0, 0, and the other root is at +2, 0. It came out nicely with our graph. Now probably at this point, some of you are wondering and asking, why is it always at a grid line? Our roots are and our y-intercepts, isn't that kind of convenient? What if it isn't? How are we going to read them off the coordinate line of the x-axis if it's not directly on a grid line? Well, later in this unit we will learn methods to find x-intercepts when they're not exactly at an integer. This parabola opens upward, and therefore we have a minimum which has the same coordinates as our vertex, of course, 1 and -2. Our domain will still be all real numbers, and our range now starts only at -2 with square brackets, but it goes on all the way to positive infinity. All right, those were the examples of how to graph or how to find the characteristics from an equation in standard form. Now go ahead and watch the second part of this tutorial about the intercept form.